Hello students, welcome to Easy Math channel. Today our topic is quadratic equation. So what is quadratic equation? A quadratic equation is a polynomial of degree 2. So how does a quadratic equation looks like and what is the standard form? So the standard form of a quadratic equation is ax squared plus bx plus c is equal to 0. Here ax squared plus bx plus c is a polynomial of degree 2. Degree is nothing but the highest power. So here we see that the power of x is 2, the power of x here is 1 and the power of x here is 0. So the highest power here is 2, that is degree is 2. So this polynomial is a quadratic polynomial, and if this is equal to 0 then this will be a quadratic equation. Here one important thing to note that the coefficient of x squared, that is a, should never be equal to 0, because if a is equal to 0 the term containing the degree, that is highest power 2, that is x squared, will vanish and this will no longer be a quadratic equation. So whenever we write a standard form of a quadratic equation, we have to keep in mind that a should never be equal to 0. Okay, so we can say that b can be 0, c can also be 0, but a can never be 0. Now how the graph of the quadratic equation looks like? So the graph of a quadratic equation represents a parabola. We will discuss graph in much detail in the next coming videos. Now we will try to understand how we can identify whether the equation is a quadratic equation. We have to do some checks, and after doing that checks we will be able to say whether the given equation is a quadratic equation or not. So let us start with the very first example. So here the equation is x squared minus 6x plus 4 is equal to 0. Each and every time we will be comparing the given equation with the standard form and try to do some checks. So this is the standard form. Now what are the checks? There are 3 checks we have to always perform while determining whether the given equation is a quadratic equation or not. The very first check is the power of x in each term. So here in the first term we see the power of x is 2. So let us write down here the power of x is 2 here. In the second term x, again here the power is 1. Cool. And in the last term, what is the power of x? We don't see any x, but if you want to write, or if you want to see x, you can write 4 as 4 into x to the power 0. Students, we all know that any number to the power 0 is nothing but 1. So we can write 4 as 4 into x raised to 0, that is 4 into 1, that is nothing but 4. So remember, whenever we want to find the power or see the power in the constant term, we can induce x to the power 0 here, which will make no difference. So the power here for variable x is 0. Now what is the condition? The condition that all the powers in the variable of a quadratic equation should be whole numbers. So these are all whole numbers. So the first condition is good. What is the second condition? Degree. Degree of a quadratic equation is 2. So degree is nothing but the highest power. So what is the highest power among this? The highest power is 2. So this is also good. The third condition or the third check is the value of a, because we have to see that a should never be equal to 0. So what is the value of a here? How to find the value of a? A is nothing but the coefficient of x squared. So coefficient of x squared is 1. So a is equal to 1, which is not equal to 0. So these 3 conditions are good and they satisfy whatever satisfy the rule. Therefore the given equation is a quadratic equation. So once again, what are the 3 conditions? Number 1, the power of x in each term should be whole numbers. Number 2, degree of a quadratic polynomial is 2. Therefore, for a quadratic equation, it is necessary that the degree should be 2 and a should not be equal to 0. Let us quickly move to the next example. So here the next example is 2x squared minus 7x is equal to 0. Let us quickly perform the checks and try to determine whether this is a quadratic equation or not. First of all, the power of x in each term. The power of x in the first term, 2x squared, the power is 2. The power in the second term, x, the power of x is 1. So we only have this term. So we see that 2 and 1 both are whole numbers. So this condition is good. What is the second rule? The second rule, degree. Degree is the highest power. What is the highest power among these two? Is 2, which is also good. We require degree 2. What is the third rule? Value of a. Value of a is nothing but the coefficient of x square. Coefficient of x square is 2 here. So value of a is equal to 2 according to the condition, which should not be equal to 0, which is not. So this is also good, as all the three conditions are good. So yes, this is a quadratic equation. Next example. 5x squared minus 7 is equal to 0. Quickly comparing with the standard form and try to determine the powers. So the power of x in each term. What is the power of x in the first term? Good, it's 2. What is the power here? As in the earlier example, I showed you, for constant term we introduce as x into x to the power 0, which will make no difference. So the power here in the second term is 1. Both the powers are whole numbers. So this condition is good. What is the second condition? Degree. What is the degree? Degree is the highest power. Highest power among this is 2. So this is also good. And finally, the coefficient of x squared, that is value of a. What is coefficient of x squared here? That is 5, which is not equal to 0. Satisfies the condition. Hence, this is also a quadratic equation. Next example. Now, before determining, we need to simplify this example. So, how we can simplify? I can write this as x plus, it will be x squared plus 3 by x is equal to x squared, and this will be written as x squared plus 3 is equal to x cube, as x will get multiplied with x squared. Hence the final expression will be x cube minus x squared minus 3 is equal to 0. Now quickly try to check all the conditions. The very first condition is power of x. So what is the power of x in each term? The power of x here is 3. The power of x in the second term is 2. And the power of x in the last term, we don't have x, but we can introduce x, so the power will be 0. All the powers are whole numbers, so not a problem. Next condition. What is the degree? Degree is the highest power. So what is the highest power among these two? 3. But we know that for a quadratic polynomial, degree should be 2, not 3. Hence this condition is not satisfied. We are not going to the next condition, not determining the value of a. Hence from this we can say that this is not a quadratic equation, because the degree is 3, it is not 2. In this example, we see that it looks like a quadratic equation, but there is something different. So let us start checking the condition. The very first condition is to check the power of x. The power of x here in the first term is 2. What is the power of x in the second term? As you know, root x can be written as x to the power half. So the power here is half, 1 by 2. And the power of last term minus 3 is 0. Now 2 is whole number, 0 is whole number, but 1 by 2 is not a whole number, it is a fraction. So for an expression to be a quadratic equation, all the powers should be whole numbers. Hence the first check fails, hence we are not going to perform rest two checks. From the first, we can say that this is not a quadratic equation. In this example, let us quickly start checking one by one. First of all, what is the power of x in each term? Quickly, the power of x here is 2. The power of x in the second term is 1. The power of x in the last term is 0. As we see, 2, 1, 0 are all whole numbers. So this is okay. The next check is the degree. What is the degree? The highest power is 2. This is good. And the last check is the value of a, that is coefficient of x square. So value of a is √3, which is obviously not equal to 0. Hence this is also good. All the three checks are good. Hence this is a quadratic equation. Again, we need to simplify this expression first, and then we will determine. So I can write this expression as x square plus 1 by x is equal to 1, and this will be nothing but x square plus 1 is equal to x, as x will get multiplied here, and my final expression will be x square minus x plus 1 is equal to 0. Now what are the checks? First, what is the power of x in each term? The power of x in each term, here the power is 2, so I'll write power 2. Power of x in the second term is 1. Power of x in the last term 0. All powers are whole numbers. First condition is good. Second condition, what is the degree of this expression? Degree is the highest power. So highest power among 2, 1 and 0 is 2. So this condition is also good. And the last check, value of a is the coefficient of x square, as x square has nothing, so we can say that it's 1. So value of a will be equal to 1, and which is not equal to 0. Hence this condition is also good. All the three conditions are good. Hence this is a quadratic equation. Now friends, we will see what do we mean by roots of a quadratic equation. Root of a quadratic equation is any value. Let us say, for example, we have a quadratic polynomial or a quadratic equation in terms of x, and for any value of x, if that value satisfies the quadratic equation, that value of x is called the root of a quadratic equation. Don't worry, we will see this by an example. So for instance, we have a quadratic equation 3x square minus 2x minus 1 is equal to 0. Against this equation, we have the value x is equal to 1. Now, how we can say that this value x is equal to 1 is the root of a quadratic equation? For any value of x to be the root of the quadratic equation, it is necessary that if you substitute x is equal to 1 in the quadratic equation, it will satisfy the equation. Now what do you mean by satisfy? That means if you put x is equal to 1 in this expression on the left hand side, it will give you right hand side. Let us see how. So let us put x equal to 1 in the quadratic equation. What will be the quadratic equation look like? It will be 3 times 1 square minus 2 into 1 minus 1. We have simply substituted value of x equal to 1 in the left hand side, and we will evaluate this and try to find out what will be the final value. So it will be 3 minus 2 minus 1, that will be equal to 0. So when we substitute x is equal to 1 in the left hand side of the quadratic equation, we get right hand side. That means this value x is called a root of a quadratic equation. So this is the concept of root. So once again, a root is nothing but a value for which if we substitute in a quadratic equation, and if it satisfies the equation, that value is called the root of an equation or a quadratic equation.